Okay, welcome to this section describing DynamoDB and what we're going to be doing with it. Now, I've placed here a basic design flow of how we're going to use DynamoDB to store our MQTT messages and our JSON packets sent from our embedded devices. So you can see this kind of design flow here is we have our embedded device, our IoT topic. We defined the rule, which I'm going to do in the next lecture through DynamoDB, creates that Dynamo action where we're going to store the message into our Amazon DynamoDB. And here's kind of another flow chart how it's going to work. Our MQTT server to Dynamo, and instead of going directly like we did in the previous lecture from MQTT to the S3 front end, we're going to go right from there into our DynamoDB, capture all this raw data, and now we have the option of going to S3 or further refining it through some type of pipelining for cleaning and transforming, then sticking it to S3, or sticking it again directly into S3, and then we can clean and transform it and run some graphing and analytics through QuickSight. And then when we talk about DynamoDB, it's important to talk about SQL versus NoSQL databases. Now, of course, DynamoDB is the default database for AWS IoT, and it's a NoSQL database. Now, I read a lot about, well, SQL's great for this and NoSQL's great for this, or not good for this, and a lot of it's like SQL's faster than NoSQL. But then I've also seen articles about NoSQL being faster than SQL depending on the document or data type. So I don't think you can really say, oh, this one's necessarily faster, or it can handle a larger amount of data, or it's not as scalable. Those are a lot of the complaints. But I can say there's a couple things that are generally true. Whatever SQL can handle, NoSQL can handle it, and generally more, as in heterogeneous data types. So for key value pairs, SQL is generally fine for the kind of data we're doing, but let's say you have documents or images, NoSQL is what you want to go for that. So NoSQL is generally a more dynamic database that you can do more with than just a straight SQL database like MySQL or Postgre. But as to the actual performance and scalability and some of these other issues, that remains to be seen, depending on specific implementation of the database. So let's move on to the next lecture, in which we will take our messages from our embedded devices and send them directly over to the DynamoDB. So once they're stored in that DynamoDB, we can manipulate them further from that point. Now that we've talked about SQL versus non-SQL databases, and we've spoken about DynamoDB in specifics, let's move on and create a rule action to put an item from our embedded device through AWS IoT into our DynamoDB. And going forward, that's kind of the way we want to store this data, whether we're working with AWS or Azure or any of these other services. Or let's say you have your own cloud where you're using MySQL with PHP. Normally, whatever kind of embedded data you're sending to the cloud or your own private server or your LAMP stack or your cloud stack, you normally want to create a database to hold all that data within. Because once you have that raw data, you can manipulate it and clean it and wrangle it and transform it and do whatever you want. But without using a database, you don't have a really fast way to query and recover it. So databases in general are an important idea, especially for IoT. And if you're planning your own IoT type related system and you're building one up for development, I would highly suggest you center it around a database so you can manipulate and whatever you want to do with that data, you're going to have options. So it's really important you understand how databases work and Dynamo in specific, because again, that's really tied into AWS IoT and that's what they're promoting. Normally for my own development, I use my PHP, but Dynamo is very good and it's a really versatile database. So let's go ahead and create an action. And what we're going to call this is my Dynamo IoT. And it's going to be our DynamoDB for holding our IoT sensor data. And we'll have all kinds of ways to partition and define that, and we can change that as the course goes on if we need to hold and manipulate and retrieve our data, scan the data, and however we want to kind of organize the data. So again, I'm going to do the same thing I did before, grab the whole JSON packet, and we're going to have the same topic, of course, which is my topic get payload or whatever yours is. That's been pretty consistent over the course of these lectures. Okay, let's add an action. And we have two Dynamo options, insert the message to the Dynamo, or the V2 where you have a multiple column aspect. We can just use the simpler one, insert a message into the DynamoDB table. And of course, we're going to configure that, and then we're going to need to create a table before we can utilize one. So let's go over to create our first Dynamo table, and let me show you what it looks like. And it's going to have some specifications and some functions to make our life a lot easier here. Okay, one thing I should mention right off the bat is you can see this provision read and write capacities. That's done by a combination of how often you're sending it data or trying to retrieve data and the size of the data package. So I'll add an insert here to give you what the exact current specifications are, but 20 units of read and write is more than adequate for our free tier usage of DynamoDB. And when you get into paid usage, it's pretty easy too. I think this is like estimated currently at like $2.30 a month if you're on paid tier for using this many units. So let's go ahead and create our table. And we can call it anything we want. So let's call it our test table. Obviously, naming these things isn't my strong point. Okay, so we're going to set up a couple partition keys, actually one partition key and one sort key. Now, this is a little bit misleading because this looks like it's super important. It's important we have one, but these end up just being arbitrary names when we get our database file completed. So we don't have to use any typing or certain conventions to name these, other than we want them arbitrarily named as what our sorting criteria is. So what's a good way to sort it? Well, I would say, again, assuming we're in production, and we might as well pretend we are, even though currently we're only using one embedded device, we might need to sort it first by which device the information is coming from. So why don't we go for device ID as our first partition? So basically every partition will have a different device ID. Now within that partition, we're going to sort it. And the sort under the partition is probably going to be our timestamp. You know, when it's coming in from the device or when it's being time-stamped by the database. We can use either one, and I'll show you how to use either one, but we'll just say timestamp. And this allows you both to have it as a string, or you can pick, is this coming in as a number, a binary, or a string? Device ID is definitely coming as a string, because remember they were given those certain device names under things as like ESP, and then some arbitrary numbers after that. So we're going to grab our thing ID, and I'm going to show you how to do that. And then this one, of course, is coming in. We can actually use this as a number or a string. We'll just keep it as a string for now, and then if I want to cast or transform it later, and I do, I'll show you how to do that later. So let's go ahead and create our database table. Okay, so this is the database view. We already created our table. It's currently making it. That's our test table. So it's creating it. We got to wait a while. It usually takes about 10 seconds. And there we go. It finally went active. And if we go over here to items, we can see under our item that there's nothing in our database right now. Test table's completely empty. So we'll come back to this after we fill it with some information. But let's go ahead with that function. And now that it's there, let's refresh this and we can go to our test table. Now that we have a table name, and it put this in for us, which is great. We have our device ID and our timestamp. Again, completely arbitrary names. Now let's go to something that's not arbitrary, that's specific. So when we have our device ID as a hash key, the way to do that is use the literal definition of it within the program that we're sending it within that JSON package, and then it's assigned to this arbitrary name. Now, if you remember in Mongoose what our name of our package was, it was device ID, but we had a problem. We had a space. Remember, it was device space ID. Unfortunately, and I shouldn't have called it that, this can't handle a space. So you need to go back to your program and put an underscore if it's not already there, then change the code and re-upload the code to the device. Because if you try, this has to be a literal value, so it has to be absolutely spelled exactly the same as what's in the program, and it can't be done with that space. Which tells you pretty much that Amazon's not using a Windows database system on the back end. I'm probably pretty sure they're using a Ubuntu-based server based on Linux, obviously, because Linux is terrible, I should say Unix is terrible about handling these spaces. So as a programmer, rule one, which I violated, is whenever you're declaring a variable name or a constant name, you should generally avoid spaces because it avoids this type of problem. And that's true whether you're naming files or folders as well. So how do we make this a literal after we do the exact same spelling? We add these brackets. And then the last thing we have to do to get this to work is add the $sign for a constant value. Okay, for a range key, we're going to use the timestamp value. That's not a surprise, but there's a pre-built-in function. It's going to give us a real timestamp on the server side. So rather than getting the timestamp defined on the device side, let's go ahead and use this built-in function. because if we can use a built-in function, that's going to make our life generally easier. It's also called timestamp. Again, we need the dollar and the braces on that, and this one also needs function notation because it's a pre-built Amazon function. And if you want to just type in Dynamo functions, AWS has a whole list of different functions you can use. Some are more useful. This is one of the more useful ones. A lot of them don't seem that useful, and there's probably a list of about 20 of them. Okay, we're going to need to have a name for this, so let's call this Enviro Data. And this, again, is just going to be a column header for a whole JSON package. And you'll see when I show you the database, it's going to say Enviro Data. Finally, I already created a role, but basically if you want to create a new role, you just hit Create, and then you'll get this test database role I already created. I wanted to do that really quick because I want to show you a problem that could occur, and I'll go to the IAM panel so you can understand how that works. And I'll update that first. All right, we're good to go. Let's add the action. Now what I want to do, and then we're done with this, so let's go ahead and create the rule. Good, and that's enabled. But what I want to do real briefly is go back into our IAM over here and see if we can find that role, because I've been having a problem, and I think it's something AWS needs to fix, and I'm guessing there's a good chance you're going to have a problem. So I want to show you how to fix this, and you need to know this anyway, so it's a good time to talk about it. Sometimes AWS IoT doesn't assign the correct permissions when it auto-generates those roles. So here's how you can easily check that you got the right permissions when you generated the role. First, you want to refresh this, because if you don't, it's not going to have the role updated. So when you go to this screen, and there it is, test database role, or however I spelled it horribly. Okay, here's what I want to look at, and if you're having a problem, this is a great place to start, because I've had this problem before, is you're going to look at the definition of the role. You want to make sure that your database table is assigned permission to this role, because I've created these roles before and it doesn't work. And then when I go back, it hasn't updated for my specific data. So make sure if you're having a problem, you check the permission and it has your data however you created it. You check the permission and you make sure it has the name of your data table here as given permission. So if you wanted to assign additional policies, and we can do that anyways even though we're not using it, because one hassle with this, we're not given permission to do everything. You're an admin and you're going to add permissions as you go. So let's say this permission isn't good enough. I can go IoT and I can get all IoT permissions. So it has all these different IoT roles, including these general ones that are like IoT full access. Or I can go over here to S3, enter that, and then I'll get these individual roles I can add in, or if I really am not under any security worry and I'm just doing it for myself, I'll go ahead and click S3 full access. But for this, we don't need it now. If we're going to need it later, I'll show you how to do that. But we checked our permission, our role is correct. So let's go back and check our database. It's all correct and enabled. So I'm going to go over to test it. Let's add in our correct topic here. My topic, get payload. I'll subscribe to that topic. Now go back to my device, and remember I've corrected that device ID so it has an underscore in the middle of device and ID. Okay, I'm going to put in, why don't we put in 5 readings here? Again, if you look at the number of units, I think we can do 20 per second at 1 kilobyte each. Obviously these are less than 20 and it's less than 1 kilobyte, so we're well under our free tier limit. I'll add 2 more. All right, that's enough. Now let's go check that they're in the database, and then I'm going to show you one other feature. So go back to Dynamo DB here. Remember our database was testable, so I'm going to click that on. Go back to items, and I just have to refresh this. Now when I refresh this, we should have those 5 items in the database. Okay, and you can see there they are. And we have our device ID, our ESP8266. Now your device may vary if you're using that ESP32 or TI3200 or any of those devices from the different IDEs that we've utilized. This is the server-side timestamp. Again, that's defined by the Amazon function. And our environmental data is just going to be our whole data package, which is the humidity and everything else we need down here. I want to show you one last thing before we move on, and that'll show you all the data here. I can perform an actions and export to comma-separated value formats. But let me unclick this so I can get all of them. I want the whole section downloaded. So let me just download this. Okay, cool. So you can see that I have all the information we need downloaded into comma separated value format. And this is pretty useful, but there's going to be more useful things we can do to extract it from Dynamo Database. This isn't super useful because I don't want to have to go into this control panel and manually download a CSV every time I want to look at the data in the table. And plus, normally I'm going to want to filter and transform this data. Even though it's CSV format, it's really nothing like we want the end product. So let's look at a couple ways to extract the data, two of which are data pipeline from AWS, as well as AWS Glue. And then we can extract and in some cases transform the data before we do our graphing and analysis. So let's move on to the next video and start getting into that.